point to
too.
write up, and I have to give them these. So,
All right. Hi, everyone. Rachel is out today, so Hal and I are taking every day. I'm going to send around this attendance sheet for y'all. Some announcements / reminders. Your midterm feedback is due Friday, which I assume means today, by 11:59 p.m. 2% points extra credit on exam 2. You do that, I guess. For next time, you have quiz 7. I think you're supposed to read Research Methods 13.2 and from that book, and then from stats, pages 406 to 409 and 601 to 604, and you have homework 5 due. You have your exam on Friday, and then your lab report, which you'll have some time, you should have time in lab today to work on, is due the Monday after the exam. Is there a TA review session scheduled?
Oh, yes. It is on Wednesday from 7 to 10.
Okay, TA review session Wednesday from 7 to 10 for the exam.
CST.
Okay, first floor of CST. Okay. So today you guys are gonna learn more about some between subjects measures, how to do independent samples t-test, a Man-Whitney U, and a chi-square as well. And so the in-class assignment is only gonna probably take a little bit of your time, and so you can then start working on your lab reports. And I would highly suggest that you work on those before the exam so you have time to get feedback or help if you want to ask TA questions. Okay, so I don't know exactly how Rachel gave me a list of ways that she organizes things, but you guys might have to help me out. So for our in-class assignments, do you guys want to hand these out for JASP people and R people?
Can our people raise their hands, please? And keep them up, please.
I should have kept one of those for myself.
Yeah. Do all our people have the R sheet?
So if you look over this handout, right, the first few pages of instructions are how to do the different analyses. You guys be quiet? Thank you. The first pages of instructions are how to do the actual analyses. If you're doing JASP and if you're doing R, I can't help you. I don't know R yet. So hopefully Rachel's videos for R will help you out. But if you're doing JASP, so there are 2 of the tests you can do in JASP, and the third we need to go to another website. So the very last page of your handout has the in-class assignment on it, which is 3 questions basically. You're looking at gender differences in blood pressure, gender differences in stress ratings, and then the gender distribution in the sample. So first of all, the data set you're using for this, I believe you guys have used before. It's the cardio data set that's on Moodle. Oh, hold on, there we go. Okay. So you have, here you have the gender of participants, race of participants, systolic blood pressure taken at baseline, systolic blood pressure taken during a speech stress, heart rate taken during baseline, heart rate taken during speech stress, and then ratings of stress that are on an ordinal scale taken at baseline and following a stressor. And so that's the data you're going to want to use for the in-class assignment. First, figuring out if there's a gender difference in baseline systolic blood pressure. So when you're looking at what type of variable is gender? Nominal. What type of variable is systolic blood pressure? Ratio. So if you're seeing if there is a difference between 2 groups in a ratio variable, what kind of test are you using? Independent means t-test, right? So that's what you're going to want to do for the first one. Your second question is there a gender difference in stress ratings taken after stress? So I told you guys already that the stress ratings were ordinal. So what kind of test are you doing? And there's a hint it tells you specifically on the assignment. The Mann-Whitney U, right? So both of those can be done in JASP. JASP, unfortunately, does not do a chi-square test, so you're going to go to another website to do the chi-square test. So if you look at your instructions, it gives you the website that you need to go to in order to do your chi-square test. Let me get back to mine. And when you pull that up, it's going to look like this. Okay? And your instructions walk you through how to do it. Basically, you enter your categories. So in this case, your categories were female and male. Click next. I think this is all in your video as well. And then you put the numbers that were observed, which you'll be able to get from the data set, and then the numbers that were expected. Did you guys already do chi-square in class? Okay. So expected, if you're looking at an equal distribution, then you're basically just taking your total number and dividing by 2. And then that will give you tell it to calculate, and it will give you the values that you need. Do you guys have questions about that part before you start? Otherwise, I'm going to show you the data file for your lab report. Okay. So for your lab report, your data file is on Moodle now. Right here, stress and anxiety survey data. And you will also need these values for your lab report that Rachel's calculated for you. For the perceived stress scale, the alpha, which is your measure of reliability, is 0.89. And for the STAI, the Spielberger state trait anxiety, your alpha is 0.94. So these are going to need to go in your lab report. But your data file's here. And this is what the data file looks like. So you have here what is the age. So you have 19 or younger or 20 or older, then domestic versus international, then the average perceived stress scale score, average STAI score, and then you have your semester data here. And so your lab report, where do I have that document? Is asking you to, have you guys gotten your lab report instructions yet? Yes? Okay. Is asking you to look at, is there a difference between younger and older students on each of these measures, the perceived stress scale and the Spielberger anxiety scale? And then you also are going to see if there's a correlation between this perceived stress scale and the Spielberger's anxiety scale. So after you finish the in-class assignment, you should start working on the lab report. Questions about anything before I just let you guys kind of like start working?
Can you explain what are those?
The PSS?
Yeah, those two values is under alpha reliability, but I don't know.
So that's the measure of Cronbach's alpha, the reliability measure for the questionnaire. So that's how you measure reliability in a questionnaire. And so that has to be reported in your lab report. And so that is going to go in the method section. So if you look at your lab report instructions, it will specifically tell you about reporting the reliability, and those are the values that everyone should have in their lab report. Other questions?
And I guess one more thing about the values, any value above 0.80 is very good reliability. So that's kind of the cutoff. I guess some people use it 0.7, but I think 0.80 and above means good reliability. So you have very reliable measures there. So that's something you should say on your lab report as well.
Yes. These are well-validated use measures. Other questions? Anything that it seems like I probably
I
forgot to
found
say or
something
do?
here in the instructions. It says go over class assignment, just output.
Yeah, see,
Um,
that's what I'm wondering
For
if.
this assignment, they need to open
if-
the cardio data, so I guess just go over it. But I don't know what go over means right now. Like I guess just tell me.
Okay. Can you guys pass these around?
It's usually really brief, like 2 minutes. Like here's
Okay.
things.
So then, I'm gonna also have the TAs pass around an example output to help you kind of see what your output will look like from JASP and what you actually need to report. What are the important parts of it?
Oh yeah, and if I can say something, while grading your problems, that I know that not all of you are rounding correctly. Check in the APA format to how many significant values, how many significant figures you're rounding your numbers. They differ. Like the p-value is different from the Cronbach alpha, so please check that for every single value you're reporting. So I did not take points up for the problem set, and I don't know whether we will take points up for that in the lab report.
Okay. So if you look at this page that they just handed out to y'all, the first thing you see is the independent samples t-test. So it says independent samples t-test, right? And then under it says pain tolerance, because that would have been the dependent variable that was examined. And then you have right under that the t-value from your test, which in this case was negative 4.767. The degrees of freedom, which in this case was 40. The p-value, in this case it was p is less than 0.001. And then Cohen's d for your effect size, in this case it was negative 1.478. So to report that in APA format, you have that to the right there. You do an italicized t, then in parentheses is your degrees of freedom, which is 40. Then equals your t-value rounded to 2 decimal points. So for this one, it would have been negative 4.77, comma, then an italicized p and your p-value, so p is less than 0.001, comma, then an italicized d for your effect size, and that's going to be rounded again to 2 decimal points, so negative 1.48. And when you're writing, you also want to interpret the effect size. So for Cohen's d, Rachel reminds you here that small is 0.2, medium is 0.5, and large is 0.8. So this would be a large effect size. And then you also see your descriptives below that of males and females, the number you have in each group, the mean, standard deviation, and standard error. And then right below that, you have what an output would look like for the Mann-Whitney U-test. So here your dependent variable is pain unpleasantness, and you're comparing genders. And so you have pain unpleasantness. Your W for your Mann-Whitney view basically is 290.0. Your P is 0.069. And then you have an R value of 0.327 for your effect size. So to report that in APA format, you're going to have a capital W that's italicized. In parentheses, you're going to have your sample size. And so if you look right below the independent samples, the Mann-Whitney U output, it gives you your descriptives. And so you see that there are 23 females and 19 males. So if you add those together, you're going to get a sample size of 42. Then equals whatever your value is. So in this case, it was 290.0, comma, your p-value. And your p should be italicized. So p equals 0.069, comma, and then your effect size. So this we report as RPB for rank by serial correlation. And you round that to 2 decimal points, so 0.33. And then on the back, it tells you how to report your chi-square test in APA format. And so again, this is the output from that website that I showed you guys. So it's going to show you, it gives you a chart, it gives you your observed, your expected, then it shows you some of the calculations, and it tells you your chi-squared value is 1.528. And at the bottom it tells you your p-value is 0.21637. So when you're reporting that in APA format, you do chi-squared, so it's chi, like the Greek letter, not an X, and that's usually italicized. And then in parentheses, you first have your degrees of freedom, which is your number of groups minus 1. So when you have male and female, that's 2 groups minus 1 gives you 1 degree of freedom, comma, your n value. So if you look at your chart and you see what your observed numbers are, you can add those together to get your n. So 31 and 22 is 53. Close your parentheses, equals, and then you round your chi-squared value to 2 decimal points. So 1.528 rounds to 1.53, comma, italicized p, and we round p to 3 decimal points. So 0.21637 rounds to 0.216. Questions there? Mm-hmm.
Is this due at the end of class? Like, do we hand it to you, or are we checking our?
You're going to check your own answers. I've got the
And then we
answers
keep
up
it
here.
in our notes.
Hmm?
Like, so then we keep our classwork in our notes, like we usually.
yes.
Okay.
Other questions?
I am going to hand you something else unrelated to today's class. That is an exam to review questions. So as you know, next week, if I am not mistaken, there's some sort of review in general.
Yeah.
So I would encourage you to